Hello, in this video I'm just going to talk a little bit about combining like terms. So whenever we talk about like terms, we mean that the variables, that we have a set of variables that are the same. So for instance, if I had like x squared, um, 3x squared, or if I had, say for example, 13x squared, we would have that these would be an example of what we call like terms. And that's because they share the same variable with the same exponent. Another example of where you can have like terms could be, for example, like if you have uh, as simple as taking 3x and then you have something like a 4x. This would be another example of your like terms. So we have that these would be also like terms. But sometimes you might have that, there's terms of which there's not really anything that you can do with. So like for example, like if you have x, y, and z, these are unlike terms. It is true that they are all variables respectfully, uh, but we have that would be that they're unlike and that there's nothing that we can do with those. Okay, so let's go ahead and just look at an example of combining like terms. So for instance, let's say that you have 3x plus 4x and you just want to simplify. Well, because these two terms are like, then that means that we can actually just simplify by combining. So we have 3x plus 4x. So the x is more or less like a placeholder. So we just treat it as that we're just adding 3 and 4. So that would mean that you would have 7 multiplied by x or just 7x. Okay. Now, similarly, what if we had an example where, you have something like 13xy minus 9xy. Now, another way that I can try to combine like terms in terms of like saying that xy is a placeholder, I can actually take out and reverse the distributive property where I have 13xy minus 9xy, and then I just take out the xy. So we can put a parentheses, 13 minus 9 multiplied by xy, and what you end up with is 4xy. So we have that would be 4xy. Now, normally you probably won't do it you won't do it that way where you reverse the distributive property. But if you do, then yeah, it gets you kind of used to treating these as, placeholders in that sense. So that means that, we can still combine like terms either just by treating it as addition, subtraction, and so on, or by reversing and then just, placing the variable last. Okay, well, let's say that we have another example. Okay, so if we have another example of trying to combine like terms, let's say that you have 3x and then you have plus 2y and then you have minus x and then you have plus y. Okay, so we have to simplify this by combining like terms. So in this sense, it may be a good idea to move all the terms that are like together. So we could say like 3x minus x, and then we have plus 2y plus y. Now, if we go ahead and we further simplify, treating this as a placeholder or just by saying, well, that's kind of like 3 minus 1, which is 2, but there's an x attached to it. So you have that would just be 2x plus 3y. Now, note that this is as far as you can go with combining the like terms. So in that sense, the solution is 2x plus 3y. Now, I'd like you to go ahead and maybe try, for example, when you have something like the square root of x plus 3 multiplied by y plus 2 square root of x and then plus y. How would you combine like terms here? Note that the square root of x, it's still a variable because you have that the square root of x is the same thing as x raised to the 1/2. Remember that combining like terms involves looking at a variable that has to be the same with the same exponent. So here you have that root x and 2 root x, those are like terms. Similarly, 3y and y are also like terms. Can you figure out what that simplifies to?